Hello everyone and welcome back to the channel. I'm excited to have you here for lesson 8. Today we're unlocking the power of two essential CATIA V5 tools, rip and slot. Get ready to create some truly complex 3D shapes. Let's start modeling.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true. Colors bright and brand new. Transforming.
Hello everyone. Today we want to talk about two tools. These tools are called rip and slot. Do you remember the pad and pocket tools? In the pad tool we had a sketch that was drawn on a plane. Then, with the help of pad, we would make that sketch 3D in a straight direction. There are a few important points here. To use pad, we only needed one sketch. With the pad tool, we can only make a shape 3D in a straight direction. To use pad, we only needed one sketch. The rip tool is similar to the pad tool. With this tool, we can also make a profile three-dimensional along a path. The only difference is that you can also make your sketch 3D along a curve. In the rip tool, we must have two different sketches. The first sketch is the profile that we want to make 3D. The second sketch is the profile that shows the path for the 3D creation. Here you must pay attention to an important point. Do you remember that in the pad lesson when we drew several geometric shapes at once on the sketcher plane? They were all recognized as a single sketch. I go to the sketcher environment using the XY plane. I draw a rectangle. I exit the sketcher environment. I select another main plane like ZX. I go back to the sketcher environment. I draw an arc. I return to the part environment. Important note, always ensure that none of the sketches are active when you return to the part environment. Right now, my arc is orange and active. I click on the screen outside the arc. Both sketches are white. I activate the rip tool. The rip definition window opens. This window has 4 sections. In the first section, At the top of the window, there are two options. The first option is called Profile. Now, the box in front of it is blue and ready. The profile is the geometric shape that we want to make 3D. Now we want to make the rectangle 3D. I click on one of its sides. It is seen that the box in front of the second option has become active. The second option is named Center Curve. This option is the curve that our profile will be made 3D based on. The box for this option is now blue and ready for our selection. I click on the arc. A preview of the shape we will have is displayed. I leave the second section and go to the third section. Two options exist here. The first is Merge Ribs Ends. If you remember, we also had this option in the path definition window. With this option, the two ends of the created shape attach to the side surfaces of the box. Here, this option does the same thing. The second option is Thick Profile. This option and the options in the fourth section are related to each other. I activate the Thick Profile option. By doing this, I want to have a hollow shape instead of a solid body. The thickness of the hollow shape is determined in the fourth section with two options, thickness 1 and thickness 2. Thickness 1 applies thickness to the inside. Thickness 2 applies thickness to the outside. The neutral fiber option is our sketch profile. Now I give thickness 1 a value of 2 mm. I click on the preview button. You can see that a hollow 3D body with a thickness of 2 mm was created. Suppose I have a cubic box. By selecting the YZ plane, I enter the sketcher environment. I draw a circle and exit the sketcher. By selecting the XY plane, I enter the sketcher environment again. I draw an arc. I exit the sketcher environment. The arc does not reach the edges of the box. I make sure that none of the sketches are selected. I activate the rib command. First, I select the circle and then I select the path of the arc. It is seen that the rib was formed, but it is limited from the sides by the size of the arc. I activate the checkbox for the merge option. I encounter with an error. I cancel the command. I erase two sketches. I start from begin. I draw a circle with a different position. I draw an arc with less curvature. I activate the checkbox for the merge option. It is seen that the edges were extended to reach the edges of the box. I click on the OK button. Note that we can also create a path with the rib command. Only here the second sketch must be aligned and perpendicular to the first sketch plane. Despite this, there are many differences between these two commands. I enter the sketcher environment using the XY plane. I draw a rectangle and fully constrain it. I return to the part environment. I go to the sketcher environment with the ZX plane. I draw a vertical line. I return to the part environment. Pay attention that none of the sketches are active. I click on the rib command. In the rib definition window, in the box in front of the profile, I click on the rectangle. In the center curve box, I click on the line. I click on OK. You can see that a cuboid was created. But here there are some differences. The amount of the profile extension depends on the size of the line. In the path command, we did not need a line profile. We could change the extension of the sketch as much as we wanted. I create a new part. To do this, I go back to the menu bar and the Start command. I click on Start. From the Mechanical Design menu, I click on Part Design. In the New Part window, I click on OK. Now we have opened several different parts. To see them, I click on the Window command from the menu bar. At the bottom of the menu that opens, you can see them. I select one of them. Now I want to explain the second section of the RIP definition window called Profile Control. Do you remember that I said to use the RIP tool we need a profile and a path? Once they are specified, the software moves the profile along the path and makes it 3D. Now I want to see how the profile is moved along the path. The software moves the profile along the path in the three different ways. These three methods are specified in the second section of the RIP definition called Profile Control. The default mode is Keep Angle. Suppose we have a circle and an arc on the page. They are created in separate sketches. Now I activate the RIP command. In the profile box, I select the circle, and in the center curve, I select the arc. Make sure the profile movement mode is set to keep angle. I click on OK. This is the most common and default mode that is most efficient for creating pipes and ducts. In this mode, the software maintains the angle between the profile drawing plane and the guide curve at the starting point throughout the entire path. Here, given that the circle and arc drawing planes were perpendicular to each other, The angle between the circle and the arc is 90 degrees at every point. This means that the profile will dynamically rotate along the path so that it is always 90 degrees to the tangent path. Application: ideal for creating pipes and cables that need to be regular and perpendicular to their paths. Now I go to the sketcher environment again with the XY plane. I draw a circle. I return to the part environment. I activate the rip command. I change the rip path finding method to pulling direction. This mode is used for situations where you want the profile orientation to be maintained along the path relative to a fixed reference, not relative to a curved path. In the rip definition window in the profile section, I select the new circle. In the center curve section, I use the path of the first circle. Now, the box in front of the selection option was turned blue. I right-click inside it and select an axis. Look at the drawn shape and the previous shape. In this case, the software tries to always maintain the angle of the profile with the y-axis along the entire path. The profile does not rotate to remain perpendicular to the path. This can cause the profile to appear tilted or even upside down relative to the curved path at curved points. Applications: when the final shape must conform to a specific manufacturing process, such as modeling with a fixed pull direction, or to create a specific geometrics where the profile orientation must always be parallel to a specific surface or vector. This angle is measured by the software at the starting point of the path. In Keep Angle mode, the software always maintains the angle between the profile and the path curve. If we want the shape of the profile's cross-section to be maintained relative to a surface along the path, we use the third option. This option named Reference Surface. This is the most advanced control mode and is used to sweep a profile onto an existing solid surface. Application: for designing channels, grooves or edges that must fit perfectly onto another curved surface of your part and their angle to the main surface remains constant. Now we want to see how the reference surface mode works. Suppose we have a solid body, a curve, and a profile like this. I activate the Rip tool. The Rip definition window opens. In the Profile section, I click on the rectangle. In the Center Curve section, I click on the curve that we drew on the curved surface. We move to the second section, which is Profile Control. Among the three options, I select Reference Surface. By selecting this option, the selection box becomes active and blue. Now I click on the curved surface of the main body. I press the Preview button. You can see that the created rib grows perpendicular to the underlying surface itself throughout the entire curved path. This is the exact difference from the Keep Angle mode. Here the rib follows the normal direction of the reference surface, not just the path tangent. This technique is essential for building stiffening ribs on aerodynamic bodies or complex curved surfaces. Now we use this option in another state. I draw a curved surface. I use the Generative Shape Design environment to draw this surface. I return to the part environment. I define a plane perpendicular to the edge of the curved surface. Using this plane, I go to the sketcher environment. I draw a rectangle and constrain it. I return to the part environment. Now I have a curved surface, a profile, and a curved path. I activate the command. In the profile option, I introduce the rectangle. In the center curve option, I click on the curve. In the profile control section, I set the control to keep angle. I click on preview. You can see the shape created. I set the profile control to reference surface mode. Now the box below it in the selection option is blue. I click on the curved surface. You can see the shape created. Suppose we now have a cube, two circular and hexagonal profiles, and a path. Note: the two circular and hexagonal profiles must be drawn in one sketch. Look at the conditions. We have two profiles that are in one sketch and an arc path in another sketch. Since the two circular and hexagonal profiles are drawn in one sketch, they are recognized as a single sketch. The curved path is on a plane perpendicular to the surface of the profiles. The path does not start from the center of either profile. With these conditions, I click on the rip command. I set the pathfinding mode to the default keep angle state. In the rip definition window, in the profile section, I click on one of the shapes. In the center curve section, I click on the arc. I click on OK. You can see that both shapes were made 3D with one path. I click on the side surface of the cube. I go to the sketcher environment. I draw a circle. I draw the circle in such a way that half of it is outside the edge of the cube. I activate the slot command. The setting window for this tool opens. It is seen that its window is like the rip settings window. Only here to create a slot there must be a 3D volume from the beginning. Now in the profile section I click on the circle. In the center curve section I select a non-parallel edge with the profile. I select a non-parallel edge of my body. I click on OK. You can see that a semi-cylinder was subtracted from the initial volume. Well, today's lesson is finished here. Please watch the lesson twice. On the second time, practice with me. Good luck. Goodbye until the next lesson.
Let's build the future. Come with me.